All right, today we are going to continue with our radical equations, but specifically focusing on the type that have a rational exponent, and rational is just a fancy word for a fraction. So all of these questions today are going to have a variable that's taken to a fraction exponent of some type. So to start this out, just like you would do if you just had a square root or a cube root or whatever, you want to get the x value or whatever your variable is that has a rational exponent alone on one side of the equation. Okay, now to actually solve it, this is a little bit different. It's going to use some exponent properties. So here's my format. This says x to the n over m power equals k some number. What you're going to do is raise each side to the power of the reciprocal. So if my fraction here is n over m, then we're going to raise both sides to the n over m power. Okay, so I just went through here algebraically to show you guys this with variables in terms of my rational exponent, and k would represent a number in the problem as well. But when I take both sides to the n over m and take both sides to the m over n power, power to a power, you multiply those exponents. So n over m times m over n. Sorry, it kind of sounds like I'm saying the same thing. This would be, if I write them in alphabetical order, the same exact thing on the top and the bottom. This just becomes 1 and cancels out that exponent. Now, what you'll have here on the other side, you'll have to actually take k to whatever that power is, and then in exponential form it looks like this, k to the m over n. Now, for our purposes, we're actually going to solve this, and so we're probably going to convert these to radical form. So I'm going to do that bottom out. It would be the n root of k to the m power. That's usually how I would write it. Also remember though, you could do the n root of k and then take that all to the m power. This is probably, the first one I wrote down is probably what I would recommend. Okay, now the deal is, if the numerator is even for your problem, so I'm just going to make something up. Let's say I had x to the 2/3 power as an example. Okay, so my numerator is an even number, and I don't know, I'm just making something up. Let's say this was equal to 25 as an example. Okay, now if your numerator is even, we're going to take both sides. I'm going to flip that fraction over. The reciprocal would be 3 over 2. So I'm going to take both sides to the 3 over 2 power. When I do that, on this side, this just cancels out. On this side, I would have 25 to the 3 over 2 power. Now, if the numerator is even, we got to think about this for a second. I'm going to change that to radical form. So that would be the square root of 25 to the third. You got to remember, if you do a square root or a fourth root or a sixth root, probably just be 2 and 4 for our purposes. I'm introducing this square root into the problem when I take both sides to that power. So with an even root, you need a plus and minus. If you take the square root of 25, that's 5. Take that to the third power, that's 125. But this question actually has 2 answers. It could be 125 or negative 125. So even numerator, you're going to need to put a plus and minus symbol when you solve that. Now, similar, I'm just going to say if the numerator is odd. So like, I don't know, let's say we had x to the 3 over 2 power, and I don't know, let me just make something up. Let's say we had 64 over here. Okay, now in this situation, to get rid of that exponent, I'm going to take both sides to the reciprocal power. So we're just going to flip 3 over 2 over. That's going to give us 2/3. Now, when I do that here, again, these cancel each other out, so my exponent would just be 1 if I multiply those power to powers. Now, over here, this is a cube root of 64 squared. Now, whenever you do an odd root, like a cube root or a fifth root, you don't have 2 answers. So there's no plus and minus here. This question would just have 1 answer. So like the cube root of 64 is 4. If I square that, the answer to that question would be 16, just as a little example. So what you got to remember, in the original problem, if the numerator is even, When you flip it over, you're really going to introduce an even root to the problem, so you need that plus and minus because you'll have two answers. If your numerator is odd, then when you flip it over, the denominator is going to, the numerator in the original is going to become the denominator, so you don't need the plus and minus if it's odd. All right, so here's what I would do. Just whenever you do the question, just look at it right away. So I'm looking at my first problem here, and my numerator, I'm just going to use n. This is odd, so I don't need to worry about a plus and minus because 3 is an odd number. Now, what you want to do would just isolate whatever we're taking to the 3/5 power here. So I'm going to get rid of the 3, do not distribute in there. So we're going to end up with x plus 1 to the 3/5 power. And then if I actually take 24 divided by 3, we're going to get 8. What we're going to do, we're going to take both sides to the reciprocal power to cancel that out. So 5/3 power. Now, on this side, those exponents, power to a power, multiply 3/5 by 5/3. When you multiply reciprocals, they just cancel each other out. So I just get x plus 1. This side would be the cube root of 8 to the 5th power. So I'm actually going to do that. So cube root of 8 is 2 to the 5th power, which is 32. Just bringing down my x plus 1. And then just one more step here, you just got to move the 1. So subtract 1, my answer to this question would be 31. No plus minus to worry about. Now, these guys at the bottom, both B and C here, have a numerator that's even. So here my numerator is even. So I need to put a plus and minus when I introduce that reciprocal exponent. Same thing here, the numerator is an even because it's 2, so I'm going to need to introduce a plus and minus because we're going to introduce, in this one we're going to introduce a 4th root, and this one we're going to introduce a square root, but both of them are even, so we're going to introduce an even root as we solve the problem. So let's go ahead and get that. In this one, we're going to get x to the 4/3 alone. So I'm going to add 4. We have 1/2 x to the 4/3 is equal to 128. Now, totally up to you, but to cancel out that 1/2, I'm just going to multiply both sides by 2 to get rid of that. That's the same concept as the exponents. We're just multiplying by the reciprocal of that fraction to cancel it out. So 2 times 128 is going to give you 256. And then to get rid of that lovely exponent, we're going to take both sides to the 3/4 power. All right, now, when I bottom out this, the bottom is a 4 for my index of my root. So I know I'm going to have to put the plus and minus. So I'm going to do 256, and then we'll take that to the 3rd. This side will just be x. Okay, now, 4th root of 256, use your lovely little card if you need to, but the 4th root of 256 is 4. So this would be 4 then to the 3rd, and then 4 to the 3rd power is 64. This question just has 2 answers, and you can plug these back in to check. So 64 or negative 64, either one of those will work as your answer for this question. This guy, we got to get rid of the 4 out in front first. Want to isolate that x plus 5 being taken to the 2/3 power. 36 divided by 4 ends up being 9. Once you're there, we're going to cancel that out. So I'm going to take both sides to the 3/2 power. When I do that, this is just going to stay x plus 5. On this side, though, I'm going to do my bottom out. So the bottom of the fraction becomes the index of the root. So this would be the square root of 9 to the 3rd. But because this is an even root, square root in this case, you need that plus and minus symbol because that has 2 possible answers. So plus and minus, square root of 9 is 3. Then we're going to take that to the 3rd. So square root being the 3 to the 3rd power, then this is 27. Okay, this is a little tricky. So I'm going to subtract 5 from both sides. So I'm going to run out of, sorry guys, I'm not on the screen, run out of space here. Okay, so I'm going to subtract that 5. So I'm just going to come up here. All right, so I'm going to write negative 5 right after the equal side, plus or minus 27. So these are going to get me my 2 answers. If I do negative 5 plus 27, that's going to give me 22. If I do negative 5 minus 27, that's going to give me my other answer, which is negative 32. So the two answers here are different. One is 22, one is negative 32. Okay, now I'm going to flip to these on the back, and I just want to remind you really quickly, if you have the 1/2 power, that is actually exactly the same as the square root. So if I have x to the 1/2, am I on the screen? I'm totally not on the screen. Let me move that. Okay, x to the 1/2 power is the same thing as the square root of x. Square root cannot be equal to a negative number. So there is a potential for an extraneous solution in these problems, and that's going to be in this question. This is really a square root. We don't want that to be equal to a negative. So if you even wanted to write it like that, you could think about it if you want to. This is really a square root of x minus 5 equals x plus 1. To cancel out that square root, or if we just wanted to use the reciprocal, we could do that too. We're going to square both sides. Now, this is one of those questions where it's a little tricky. Don't distribute that exponent to this x plus 1. If you're squaring something and there's adding or subtracting in there, you got to do like a box or a foil, whichever one you like better. I'm just going to do foil in the paper here. So x times x would give you x squared. X times 1 will give you 1x. Then I'm going to get 1 times x, which is another 1x. And 1 times 1 is 1. So all simplified here, we'd have x squared plus 2x plus 1. And I'm just going to bring down the rest of this, which is 5 minus x. This is going to end up being a quadratic. So I want to go ahead, set this equal to 0. If you want to factor, make sure you keep your squared term positive. To do that, I'm going to subtract 5 and add x to both sides. I'm going to add x, subtract 5. So I'm going to get 0. That's the goal. You want to set it equal to 0. X squared plus 3x, 2x's and 1x, and then 1 minus 5 would be negative 4. Now, at this point, if you prefer, you can use the quadratic formula right there, or I promise I will give you something that's factorable. So if you can find the factors, I think that can make the problem a little bit faster. For this particular problem, I'd need two numbers, multiply to get negative 4, and add to get that number in the middle, which is 3. So the only way to do that, we would have to use a positive 4 and a negative 1. If I multiply those together, that'd give me negative 4. If I add them up, I would get 3. So then your two answers are what set those equal to 0, negative 4 and 1. And I just, oh sorry, I'm off the screen a little bit here again. Now, let me move this out though. Okay, so we got to go back and check. So I have really in that original problem a square root equal to this expression. So we just got to make sure our answers, if we plug them in, are not going to make that expression negative. So here, if I go back, if I plug in negative 4 to x plus 1, negative 4 plus 1 is negative 3. So this is not good. The negative 4, we didn't do anything wrong. Our algebra was all correct, but that's going to be an extraneous solution because it gives me a square root equal to a negative. Now, if I plug in the 1 plus 1, just make sure it doesn't make that expression negative. 1 plus 1 would be 2, so that makes a positive value. So 1 would be the answer here. This negative 4, we didn't do anything wrong, but it's just an extraneous solution because it doesn't work in the original problem. So just 1 would be the answer to that question. Okay. Now, this one is really tricky. So we have this is really a square root, and this is really a fourth root. So if you have two different exponents, which I do here, you want to try to think of a number that would cancel out both of them. So if I just did the reciprocal here, then we would just take both sides to the second power. If I did that here, I would take both sides to the fourth power. I want to think a number that would cancel out both. And if you can think of a lowest common denominator between those two numbers, which between 2 and 4, it would just be 4, just use that and that should cancel out both. So, because we got to do the same thing to both sides. We can't do one thing to one side and one thing to another side. So I'm going to take both sides to the fourth power. what's going to happen when I do that? This will be 2x plus 1 squared. Half times 4, power to a power, you're going to multiply those exponents, so that would become squared. Now this side, these are reciprocal, so when you multiply them together, the 1/4 times the 4, that just becomes 1, so those would cancel. So this would be 3x plus 4. Now what we need to do here, remember, don't distribute if you've got adding or subtracting inside those parentheses. We got to do a little FOIL on this question. So I'm going to multiply this out. 2x times 2x is 4x squared. 2x times 1 is 2x. I'm going to turn around and get the same thing. 1 times 2x is 2x. 1 times 1 is 1. So I have 4x squared plus 4x plus 1. And then just bringing this down, 3x plus 4. Oh my goodness, sorry guys. I'm really bad at staying on the screen today. Okay, I'm going to set this equal to 0. So subtract 3x, subtract 4. And so we're going to get 4x squared plus x, and then minus 3. Now, I'm going to promise you that this will be factorable, but it's a little harder when you have the number in front. So I'm just going to review real quickly with you guys, and you could use this for any of these quadratic equations. Review with you how to do the quadratic formula to solve this, just as another example. So, quadratic formula. Negative b plus or minus square root b squared minus 4ac all over 2a if you have 0 equal ax squared plus bx plus c, which is what we have there, then x values can be found using the quadratic formula. So I'm just going to use that here as an example so you guys can see that. My a value would be 4. Now you just have one x here, so the b value is 1. And c value is your plain number, which is negative 3. So I'm going to plug those guys in to the quadratic formula to help me solve this. So opposite of b would be negative 1 plus or minus square root 1 squared. 4 is part of the formula. A value also happens to be 4 here, and the c value is negative 3 all over 2a, so it would be 2 times 4. Okay. Now, I do this maybe in a couple steps, so I'm just going to simplify what's under the radical. So I'm doing the 1 squared minus 4 times negative 3. So just under the square root would be 49, and on the bottom here would be 8. That's nice for us because 49 is a perfect square, which it's just going to be 7. And so to get my two answers, I'm going to do, if I do negative 1 plus 7, negative 1 plus 7 would be 6 over 8, which would reduce to 3/4. And on the, if I do negative 1 minus 7, that'd be negative 8 over 8. So then my other answer is negative 1. All right, now in terms of checking both of these really quickly, I'm going to zoom back out so you guys can see the original problem up here. Now, the original problem, I really have, this is a square root and this is a 4th root. And for either one of those, I cannot do that for a negative number. So if I just go ahead, I'm going to plug it in, make sure it doesn't make that expression negative. So if I do 2 times negative 1 plus 1, I'm really taking the square root of negative 1. So this is not an answer because I can't take the square root of a negative. And you could check it over here too. If you do 3 times negative 1 plus 4, that one would be okay, but it would not be okay here. So we can't take the square root or a 4th root of a negative number. Now, if I plug in 3/4, I'm just making sure this doesn't make this negative. It doesn't matter. I got 2.5. It doesn't matter as long as it's positive. If I do 3 times 3/4 plus 4, as long as that number is positive, you're good. So the answer to this question would be 3/4. The negative 1 would be extraneous in that situation because in the original problem, we can't take the square root of a negative. And if I plug in negative 1 here, it makes us take a square root of a negative. So that's not possible. Okay, now I have one at the very end, and this is really a weird question, but it's not hard. So you do have two radicals here. I have square root of x minus 9, so the whole thing under the square root. And then I have this square root of x, but the minus 1 is not under the square root. Those radicals are as isolated as they're going to get. And what you want to do to solve this, I am going to cancel out the square root by squaring both sides. What happens over here is I have to square this x, square root of x minus 1. I'm going to show you how to do that. We're just going to do like a little FOIL. What's going on here? Square root and squared cancel each other out, so you just get x minus 9. Now this is going to look weird, but you can do this. So this is a FOIL. We're going to do square root of x minus 1 times the square root of x minus 1. All right, cannot distribute that exponent there. Now, square root of x times the square root of x would become the square root. You would do x times x, so you would get x squared. We'll just go back and simplify in a second. Okay, square root of x times negative 1 would be negative 1 times the square root of x. We would just put the number in front. We're going to turn around and get the same thing. We're going to get another negative 1 times the square root of x. And then I'm going to do negative 1 times negative 1, so that's 1. All right, now, what's nice about this first one, the square root and squared do cancel each other out, so this is just actually going to simplify to be x. Now, I have, these are like radicals. Negative 1 minus 1 would be negative 2 square roots of x. And then we just had this plus 1 down here. I'm going to bring down the rest of this. Now, the nice part first here, this x and this x, if I try to get all my x's on one side, the plain x's I have there, those are going to cancel each other out. You're going to get negative 9 equals negative 2 times the square root of x plus 1. This turns into more of a radical equation like we were solving in the last lesson. So I'm going to go ahead and move the 1. Okay, so then we're just going to move the 1. So we get negative 10, negative 2 roots of x. And don't just go, oh, I've got a radical equal to a negative. No, no, no. Got to get it all by itself. So I'm going to divide by negative 2. And I'm just going to come over here and write this down here. Now, negative 10 divided by negative 2 ends up being 5. So 5 is equal to the square root of x here. So then to cancel this out, we're going to square both sides. And we're going to get 25 is equal to x. Now, you got to make sure you don't take the square root of a negative. So just the original problem up here. So 25, here I'm just going to check it. So 25 minus 9 should be equal to square root of 25 minus 1. All right, 25 subtract 9 is going to give you 16. This is square root of, oh my gosh, 25 minus 1. So this is 4. Square root of 25 is 5 minus 1. 4 equals 4. We're off the screen, forgive, but we don't have an extraneous solution or anything there. So 25 would be the answer to that question. Just got to make sure you're not taking the square root of a negative.